This is a guide for the topic ellipse. As we all know, we have two types of ellipse, the vertical ellipse and the horizontal ellipse. Both ellipse has its vertices. We also have two co-vertices for an ellipse. And we have the center, just like the circle. This is a central conic. Okay. So for the properties of an ellipse, we have the principal axis. This is the principal axis for a vertical ellipse, and this is the principal axis for the horizontal ellipse. And in the principal axis, we have the vertices, and from vertex to vertex, that would be the major axis. Same with this one. Vertex to vertex, vertex to vertex. From co-vertex to co-vertex, that would be the minor axis. And for an ellipse, we also have the foci. For easy guide, we will name the center to vertex, this one, as A units. So the same with this one and this one. From center to vertex, A units. So if we double this one from vertex to vertex, that would be 2 times A units. And from co-vertex to center, or from center to co-vertex, this one, and this one, this one, and this one, we will call that as B units. And from co-vertex to co-vertex, that is, the length of the minor axis is 2 times B units. And for center to focus, this one, center to focus, center to focus, we have C units. For a vertical ellipse, we have the formula x squared plus y squared equal to 1. But to give you an idea, if we have a vertical or a horizontal ellipse, for a vertical ellipse, we have A squared, B squared. So you see? So this depicts the vertical ellipse. But for a horizontal ellipse, same orientation, but this time A squared is with x squared and B squared is with y squared. So this is for a horizontal ellipse. So another property that we have two remember is that A units is always greater than B units. Or the distance from the center to vertex is always greater than the distance from the center to co-vertex. So we have the following formula. C squared here is A squared minus B squared. To give you an example, let us consider the given for x squared plus 9y squared equal to 36. If we are to find the center, the vertices, let's call this as v sub 1 and v sub 2, the co-vertices, w sub 1 and w sub 2, the foci, f sub 1 and f sub 2, the length of the major and minor axis, and sketch the graph. So again, the formula for a vertical or horizontal ellipse is always equal to 1. Okay, so we have 4x squared plus 9y squared equal to 36. If we are to convert this as the standard form of equation, we have to divide this by 36 to make it equal to 1. So you divide both sides of the equation by 36. So we have 4 over 36 x squared plus 9 over 36 y squared equal to 1. And this is, if we simplify this is just x squared over 9 plus y squared over 4. We have 1 over 9 and 1 over 4 equal to 1. Okay, so if we evaluate the equation here, since A is always greater than B, then we have A squared is equal to 9 and B squared is equal to 4, since this is larger than this one. And another thing, since 9 is greater than 4 and 9 is with x squared, then we have a horizontal ellipse. That is the orientation of our ellipse. So whoever is bigger and with x or y, then that determines the orientation of the ellipse. Since a squared here is equal to 9, then a is equal to the square root of both sides of the equation, then that is equal to 3 units. And since b squared is equal to 4, that is b is equal to 2 units. And using the formula, c squared is equal to a squared minus b squared, and a squared here is 9, b squared here is 4, and that would equal to 5. And c is equal to the square root of 5. So what is the length of the major axis? Length of the major axis, we have 2 times a, and that is 2 times 3, that is equal to 6 units. Length of the minor axis is 2 times b, so we have 2 times 2, that is equal to 4 units. So what about the center of the ellipse? Since this form is an ellipse having, that is the simplest form of equation for an ellipse. We only have x squared and y squared. So we have the center is at the origin. Okay, since we have a horizontal ellipse, center at the origin, and since the length of the major axis is 6 units, with a equal to 3 units to the left and 3 units to the right, to have a total of 6 units. This is vertex 1 and vertex 2, or the other way around. So we have vertices at, so we can have, this is -3 and +3, 0. Or we can have this as 3, 0, and -3, 0. So either of the notation will do. Next is the co-vertices with 2 units from the center, 2 units up and 2 units down. So we have 1, 2. This is one of the co-vertices, and 1, 2, another co-vertex. So for co-vertices, we have this point and this point, and the coordinates for those points are 0, positive, or -2. Or we can have 0, +2 and 0, -2. So for the foci, since c is equal to square root of 5, and that is approximately 2 point something, and that should be along the major axis. So from the center, we have 2 point something here. You have the focus and another focus. So for the foci, we have, so since the vertex and the foci is on the major axis, they should have the same orientation. So we have positive, negative, square root of 5, 0. Or we can write it as square root of 5, 0, and negative square root of 5, 0. So we have solved for the coordinates of the center, vertices, co-vertices, foci, the length of the major axis and the minor axis. And if we continue this, we connect all the vertices of the ellipse, then we have it here. So just practice. So just imagine this is a circle that is compressed. That is the ellipse. So you practice that one. To have almost an ellipse. Not a diamond, but an ellipse. Okay, how about the principal axis of the ellipse, if we are to find? So since it is centered at the origin and a horizontal ellipse, then this is the principal axis with an equation y equal to 0. Another equation, what if we have 25x squared plus 4y squared equal to 100. Same question, that is to find the center, the vertices, the co-vertices, foci, length of the major axis, length of the minor axis, and sketch the graph. So first step is to have this equal to 1. So to do that, we will divide both sides of the equation by 100. So we have x squared over 4 plus y squared over 25 equal to 1. And 25 is greater than 4. And 25 is with y squared. Then we have a vertical ellipse. And a squared here is equal to 25. B squared is equal to 4, where a here is equal to square root of 25, that is equal to 5. B is the square root of 4, which is equal to 2. And C squared is equal to 25 minus 4, and that is equal to 21, where C is equal to the square root of 21. And approximately that is equal to 4.6. Okay, since this is a standard form with center at the origin. So since we have a vertical ellipse, centered at the origin, A here should be on the y-axis. So 1, 2, 3, 4, and 5. So this is the first vertex. 1, 2, 3, 4, and 5. We have another vertex. So the coordinates of the vertex, vertices are 0, positive, negative, 5. And the co-vertices, we have 1, 2 units to the left and 2 units to the right of the center. So co-vertices here, we have positive, negative, 2, 0. And the foci is at the point along the principal axis or along the major axis, 4.6 units from the center. So 1, 2, 3, 4.6. So we have one focus. 1, 2, 3, 4. Another focus. And if we connect the vertices, we have the ellipse. The coordinates of the foci, 0, positive, negative, square root of 21. And the principal axis here is this axis and has the equation of the line x equal to 0. So the general equation of an ellipse is like the circle ax squared plus by squared plus cx plus dy plus e equal to 0. But this time, a is not equal to b and should not be equal to 0. So these two numerical coefficients should not be equal to 0. So if we have the given equation, 25x squared plus 16y squared plus 150x minus 128y minus 1119 equal to 0. So since a here is not equal to b, then we can rewrite this equation as 25x squared plus 150x. You regroup all x and all y's and transpose the constant. So we have plus 16y squared minus 128y equal to 1119. So from this, we have to factor out 25 from this group. So we have 25. So since we factor out 25, that only means that over 25 over 25. So we have x squared plus 6x plus, this time, we factor out 16. So we have y squared minus 8y equal to 1119. So here, we simply divide by 16. Divide by 16. So we get this 1. Next is, we complete the trinomial, the perfect square trinomial. So we have 25 x squared plus 6x using the formula 6 divided by 2 or b over 2 then squared. So we have 6 over 2 squared. We have 9. So we add this here plus 16 y squared minus 8y. Same process, 8 over 2 squared equal to 16. So plus 16 equal to make the equation balanced, we have 1119 here plus the number that we added on the left side of the equation, that is 25 times 9. We have 225 and 16 times 16 we have 256. So from this, we have 25 times the factors for this trinomial. We have x plus the number. After we divide by 2, we have positive 3 squared plus 16. The number times y minus 8 divided by 2, that is 4 squared equal to, this will sum up to 1119 plus 225 plus 256. We have 1600. Okay, so from this, To make it in standard form of equation of an ellipse, we divide both sides of the equation by 1,600. So we have x plus 3 quantity squared over what is 25 divided by 1,600. That is 1 over 64 plus y minus 4 squared over 16 divided by 1,600. That will give us 1 over 100, and that is equal to 1. And since 100 is greater than 64 and 100 is with y, then we have a vertical ellipse. Another, since getting the standard form of equation, we have plus 3 here and minus 4. So that means we have an equation of an ellipse with centered at HK. From x squared over a squared plus y squared over b squared equal to 1, x squared over b squared plus y squared over a squared equal to 1. Both of these equations have center at the origin. And from this too, we have x minus h squared over a squared plus y minus k squared over b squared equal to 1, and x minus h squared over b squared plus y minus k squared a squared equal to 1. And these equations have centered at HK. So we have horizontal, horizontal, vertical, vertical ellipse. So from the previous example, we have x plus 3 squared over 64 plus y minus 4 squared over 100 equal to 1. And we have a vertical ellipse. So from this, we have a squared equal to 100, always the bigger of the two. And a here is equal to 10, b squared is equal to 64, and b is equal to 8. So c squared is equal to 100 minus 64 equal to 36, and c is equal to 6. So since we have a vertical ellipse, and this ellipse centered at, so same with the circle and parabola, if we have positive 3 here, together with x, we have negative 3. And if we have negative 4, we have positive 4. So we have 1, 2, 3, 1, 2, 3, 4. So you have negative 3, positive 4 as the center of the ellipse. And we have a vertical ellipse here. So we make use of the distance A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Another 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have the vertices here, and the co-vertices sideways We have 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. So we have the following co-vertices. The foci, we have 1, 2, 3, 4, 5, and 6. We have 1, 2, 3, 4, 5, and 6. So if we connect this, we have not a circle, but an ellipse. So for the coordinates of the vertices, we have, so from the origin, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, 13, 14. We can simply count along the y-axis and the x-axis, but we can also, since this is negative 3, positive 4, and if we go up, so we should add and subtract 10 from 4. So the vertices is along the major axis. So we have x here is negative 3. And since the distance from the center to the vertex is 10 plus 4, so that will give us 14. And the other vertex has the coordinates negative 3, but this time 4 minus 10, we have negative 6. We have 1, 2, 3, 4, 5, and 6. We have negative. We are on y equal to negative 6. So since we go sideways for the co-vertices, since we have a vertical ellipse, so for co-vertices, we have 4 here, but on the first coordinate, we have negative 3 plus 8, since we have 8 units to the right, so negative 3 plus 8, that is positive 5. And the other, negative 3 minus 8, so we have negative 11. For the foci, one focus is on along the major axis, so they have the same first coordinate with the vertices, but the second coordinates are 4 plus 6, we have at 10. And we have 4 minus 6, we have negative 2. So the principal axis here is where the major axis is, and this is the equation of the line x equal to negative 3. Another example, what if we are given properties of an ellipse and we are asked to find the equation of the ellipse? So if we have the center is at 4, negative 2, and one of the vertex is at 9, negative 2, and one focus is at 0, negative 2, to find the equation of the ellipse, let us first plot the given points. So we have 4, negative 2. You have the y-axis and the x-axis. So you have positive 4, negative 2. So we have the center here. And one vertex is at 9, negative 2. So for 5, 6, 7, 8, and 9, negative 2. So we have the vertex here. And focus, one focus is at 0, negative 2. So 0, negative 2. And since our points are horizontally oriented, then we have a horizontal ellipse. Or we can say that the major axis is where you can find the focus and the vertex and the center of an ellipse. So since the major axis is horizontal, then we have a horizontal ellipse. So for a horizontal ellipse with center at HK, we have x minus h squared over a squared plus y minus k squared over b squared equal to 1. And if we simply substitute, since we have the center at 4, negative 2, so h is equal to 4 and k is equal to negative 2. So x minus 4 squared over, we have the a squared here later, plus y minus negative 2, so that makes positive 2 squared over b squared equal to 1. So we should find a, b, a and b, since we need a squared and b squared here. So for a, since a is the distance from the center to the vertex, so what is the distance between the center and this one vertex? We have 9 minus 4, we have 5 units. So we have a squared is equal to 25. 5 squared, we have 25. And since we have c here, which is the distance from the center to the focus, so we have 4 minus 0, since x here is 0, so 4 minus 0, we have 4. So c squared is equal to 16. So from here, using the formula, c squared equal to a squared minus b squared. So b squared is equal to, we transpose. So if we manipulate the formula, we have b squared is equal to a squared minus c squared. And since a squared is equal to 25 and c squared is equal to 16, so b squared here is equal to 9. So we have a squared and b squared here. So since we have a horizontal ellipse, the number below x minus 4 quantity squared should be the greater number between 25 and 9. So that should be 25. And we have 9 here. So this is the equation of the ellipse. Given the property centered at 4, negative 2, vertex at 9, negative 2, and focus at 0, negative 2. So to complete the graph of the ellipse, we have 4 units here to one focus. So to the other side, 1, 2, 3, and 4, we have another focus. And since we have 5 units from the center to the vertex, so we have 4, we have the another vertex here. That is 5 units to the other side of the center. And since we have the distance b equal to 3, since the square root of 9 is equal to 3, So the co-vertices has the coordinates 1, 2, 3, and 1, 2, 3 from the center. So to connect the vertices, we have the ellipse.